Hello, friends. Welcome to this session of system design. System design is a very complex process and it requires a continuous improvement based on evolving situation. Now, there is no one shoe fits all kind of formula here, but once you understand the fundamentals, you can build any design based on your requirement. If you have any questions, then feel free to write under the comment section. Now, so without further delay, let's get started on this exciting journey of system design. To understand the concept of system design, let's take a simple server setup. In this particular example, you have one web server which is running all components inside it, which is a database, a web application server, and cache, etc. etc. So, in this particular workflow, client will initiate a request to the server using a server name. Uh, but the communication over the internet, as you know, it happens using IP addresses. At this point of time, client may not know the IP address of the server. It only knows the user-friendly name. So this request is initially sent to a DNS. DNS, you can consider it as a telephone directory which contains the names and IP addresses of the server. So once DNS server gets the request, it will resolve the name and IP address and it will return back the IP address to the client. Client will use that IP address and it will forward that request to that particular web server. Web server will process that request and return back the response which appears on the client. Now, in this whole process, you might get a question. Uh, how come your client knows the address of your DNS server? So answer to that is when a router connects to your internet service provider, it usually retrieves the DNS server address as a part of configuration. So when you connect to a network, your device typically gets these DNS addresses automatically through DHCP, which is Dynamic Host Configuration Protocol, which stores them in your network setting. Now let's see how domain name system works. Domain name system typically will have four components. The first one is a recursive DNS server, second one is a root server, third one is TLD server, which is a top level domain server, and the fourth one is authoritative DNS server. Now, in this particular example, user is requesting for a server name example.net. That request is sent to a recursive DNS server. DNS server will forward that request to a root server. Root server will resolve the uh, name of the top level domain from this server name and it will return the address of the TLD server. This request is then sent to a TLD server. TLD server, you can have multiple TLD servers here, like you can have .NET, .com, so on. So the TLD server will contain the address of the authoritative DNS server, which is written back to the recursive DNS server. And again, your request is sent to the authoritative DNS server, which will contain the mapping of your IP address. That IP address is sent back to the user via recursive domain server. So this is a very simple end-to-end workflow which tells you how when you're typing example.net on your browser's web page is getting uh, transformed into a valid IP address. Now let's see how this whole domain name system is maintained on the internet. ICON is managing all that domain name maintenance on the internet. So this whole process has three different roles involved in it. The first one is a registry, second one is registrar, and the third one is registrant. Now let's see one by one what are these. A domain name registry is an organization that maintains top level domain names. They create domain name extension, set the rules for the domain name, and work with the registrar to sell those domain names to the public. Now, one such example is VeriSign. So, VeriSign manage the registration of .com domain names and their domain name systems. Registrar. Registrar is an accredited organization. Now, in this example, I'm using GoDaddy. So, they sell domain names to the public. Some have ability to sell top level domain names like .com, .net, .org, or it could be a country specific domain name like uh, .us, Canada for .ca, Europe like .eu, etc. And registrant is a person or a company who registers a domain name. Now the whole process becomes it's initiated from a registrant. So if you, in this case, for example, if you want to start your own service, the first step you will do is you will find out what should be your domain name. You can check your domain name by going to website like GoDaddy, or you can also go to ICANN website and you can look up for that particular domain name. If the domain name exists, it will give you its information. If not, then you can consider it as your domain name. And you can go to a website like GoDaddy and you can register for that domain name by paying fees. GoDaddy will have its own process to verify uh, if that domain name is available. So again, it will also interact with the who is server and it will r- try to find out if there is any domain name with that name. If the domain name does not exist, then it will initiate your registration process and it will sync up with the registry. In this case, uh, VeriSign. And VeriSign will again repeat the same process to verify everything. If it's a new or non-existing request, then it will register in its own whois server, and all that information is sent back to the registrant. And maybe like within 48 hours, when all this whole all the servers get synced up, your domain name will be up and running. Now I'm sure you have understood how DNS server works. Now let's return back to our simple server setup. Now, over a period of time, if the demand for your services increases, obviously you will need more resources to fulfill those requests. So, there are two ways you can do that. One is either increase the configuration of your present server, which, or the second one is allocate more servers. Now, both these methods have their own advantages and disadvantages. If you're increasing the configuration of your existing server, like CPU, memory, etc., to service more clients, it is called vertical scaling. And when you're assigning more servers to allocate or to fulfill the client's request, it is called horizontal scaling. Now, scalability in generally, when we say the word, use the word scalability, it means the ability to grow. It means when your system needs more resources, how can you grow your system? Either you can scale up or you can scale out. But it also means the flexibility of scaling down. Meaning, if your network traffic is reducing and if you need less server for cost cutting, etc., then your system should be able to scale down also. Now, Choosing between vertical scaling or horizontal scaling is a $1 million question. Uh, it depends upon a lot of factors based on your situations. For the basic one is a cost. Now, initial hardware cost for horizontal upgrades are higher. For example, if you have a tight budget and you need to add more resources to your infrastructure quickly and cheaply, then vertical scaling may be the best option for you. For example, if your network traffic increased, add more memory or more higher CPU, you are done. For future proofing, adding additional updated machine through horizontal scaling will increase the overall performance threshold of your organization. There is a limit to how much you can vertically scale a single node, so it may not uh, handle the demands of the future. For example, there is only a limit to which you can keep on adding higher CPU or a memory to a system. There is an upper threshold for it. After that, you will have to move to horizontal scaling. So if you know the trajectory of your demand, and if horizontal scaling suits you, then go for it. Then it also depends upon topographic distribution. If you plan to have a nationwide or global clients, it is reasonable to distribute your system and go for your horizontal scaling. Now, reliability. If you want a more reliable system, then horizontal scaling may offer you a more reliable system. It increase redundancy and ensure that you're not relying on a single machine. For example, if one machine fail, easily all existing clients can be moved to another machine, and once the previous machine comes back up, you can again redistribute the clients. Sometimes there is no straightforward answer to choose between horizontal versus vertical scaling. It depends upon lots of realistic scenario. For example, if the cost of horizontal scaling is out of budget, then obviously you won't go for horizontal scaling. Doesn't matter how many benefits it provides. Similarly, if your system is very outdated and it cannot benefit from horizontal scaling, then you don't have a choice. You have to go with vertical scaling. Sometimes you have to choose a middle path. You will have to use a blend of horizontal and vertical scaling, meaning you can improve your servers and you can also increase some of those servers. So you will get benefit of both. Now, in our case scenarios, our clients do not have any issue with the budget, and we do not have any technical issues by opting for horizontal scaling. So we have added a load balancer here, and we have added more servers in our design. Now we are going to discuss into more details in our next session. Until then, thanks for watching.